Hello, welcome to the channel. Welcome back to the video series where I am providing a high-level overview of the Site Planning and Design Handbook. This video is about Chapter 9, and that is Landscape Restoration. The landscape ecology is a broadly interdisciplinary science. Ecologists, physicists, biologists, and geographers are as concerned with values and ethics as they are with the systems approach of this new science. A new language, a new means of describing the ecosystem is beginning to emerge from their work. Landscape ecology offers important information for those engaged in site planning and design. By understanding the principles of landscape integrity, the site planner can incorporate these elements into the site design. Landscapes can be described in terms of four general elements of vegetative mass and form, and those are patches, edges, connecting corridors, and mosaic. And that's based on the Dramstad's work in 1996. So patches are concentrations of habitat type, most commonly visualized as a woodland patch in the midst of farmland or an urban area in the middle of a national forest. Patches may be small, such as an undeveloped city lot, or large, such as a park. Um, Also, patches can arise from human activities such as farming or urbanization, from natural resource distribution such as a desert spring or emergent wetland, or from natural succession of homeostasis. Also, it can be some intervening disturbance as well. Not too long ago, patches were considered less than optimal, and they were described as degraded islands, disconnected areas as isolated from the rest of the ecosystem. But actually, patches can be beneficial depending on their character, size, and location. The quality of the habitat is also a function of size. The smaller the patch size, the less diverse it is because the number of possible habitat types is reduced. The edges or boundaries between different habitat types are blurred. There is no bright line between the meadow and the deep woods or between upland and other water. These zones of transition are called ecotones, which contain aspects of both areas and are often the most productive parts of a landscape. The littoral zones are the transition from upland to open water are usually more productive than either the upland or the open water. Then let's talk about the value of the connecting corridors, and it increases with the fragmentation associated with the human activity. With the encroachment of development and farmland, natural habitat has routinely been cut up into patches and isolated. Even patches located near one another can be isolated by barriers such as major highways, railroads, or fences. Linear developments like electric transmission corridors or pipelines prevent the movement of wildlife, but connecting corridors such as floodplains may serve as pathways from one patch to another. And then the final little section is mosaic, and that refers to the overall form of a landscape, the pattern of patches, edges, and connectivity. Even though the landscape mosaic itself is usually beyond the scope of a given land development project, the site planner must understand how a site fits into the landscape mosaic to incorporate the principles of patches, edges, and connection into the plan. So when we talk about restoring landscape, reclamation projects are usually undertaken on landscapes in which features have been obliterated by development, agriculture, or mining operations. Reclamation projects usually require construction of new landscape features to replace what has been lost. Reclamation projects might include constructed wetlands, infiltration features such as rain gardens, or eliminated invasive, toxic vegetation and encouraging the return of native species. Remediation activities are concerned with mitigating a condition that has resulted in a degraded landscape. Dealing with acid mine drainage or contaminated runoff from a brownfield site are example of landscape in such of remediation. Landscape restoration is an area of professional practice, and it has grown dramatically in recent years to become a major area of practice and innovation. When we talk about restoring vegetative cover, the agglomeration of soil into aggregates as an important element of a healthy soil ecosystem, um, and also on but that cannot be accomplished within the time frame allowed for revegetating a disturbed site. So on the disturbed site, the structure of the soil is destroyed through the operations of grading and compaction. And the loss of soil structure results in a decrease in soil permeability and an increase of erodibility. Site preparation. Collection of the soil sample is a function of the homogeneity of the soil, the ease of collection, and the construction of the sampling equipment. When contamination might be an issue, the required decontamination procedures may affect the collection of soil samples. Soil sampling can be done using aerial photography, USGS, site maps. The character of the sample is a function of the objective. Different types of samples are required for different analysis. Bulk densities require an intact core, and nutrient analysis requires a well-balanced composite sample. Soil sampling may also be done for other purposes, like geophysical techniques use profiling or sounding methods to identify the presence of buried metal objects or to map the subsurface features. Profiling is used to define the lateral extent of a feature, such as an area of buried waste, and the result is a contour map of the area or object. Ground penetrating radar, or GPR, provides a shallow cross-section of subsurface objects. GPR can penetrate up to 40 feet in sandy soils, but is limited to the first 4 feet in clay soils or soils containing conductive wastes. Electromagnetic exploration, or EM, includes several techniques that contrast the conductivity of material being screened. These techniques are useful for mapping metallic plumes and locating buried objects such as tanks, pipes, utilities, or drums. Seismic refraction is a geologic investigation tool with only limited application in environmental site assessment work. It is used for mapping bedrock surface and may be useful in groundwater or environmental pathway studies where influences over contamination plumes are being sought. Other soil testing methods include soil gas studies, which identify the presence of VOC or volatile organic compounds, such as solvents, oils, gas, and cleaning fluids. So all the tests provide a fundamental data for determining the characteristics of the soil and the cultural requirement and amendment necessary for a successful revegetation effort. In addition to examining the soil, a visit to the area surrounding the site to identify local vegetation can provide important information on native plants and the climate and precipitation requirements for the proposed vegetation. Please refer to the textbook. You can see planning and collecting soil samples. And also, we continue with the plant materials selected to stabilize and revegetate the site. So they must be able to establish quickly in the harsh environment. In general, native species are a good choice as they have predictable performance and growth habits in the geographic area. The introduction of acrylic polymers in recent years has improved the success of stabilization and revegetation process, particularly in drafty soils. So acrylic polymers are added and mixed with soils to create a film that allows air and water to penetrate but still binds the soil particles together. It is considered non-toxic and runoff does not stain concrete. Throughout the US, the regional offices of the Natural Resources Conservation Service, or NRCS, and the various state universities and agricultural colleges provide recommendations for seed mixtures for effective erosion control. And these offices are a good source of information, but when the design professional is working on the site proposal, they should consider the various mixtures in light of the specific application. Cultural operations. So seed bed preparation generally occurs after finish grading is completed. However, the surfaces to be seeded are hard or smooth and not ready to be seeded by any means. So the surface that is left with many locations for seed needs to become established. Otherwise, seeds will be blown or washed from the location. So compaction can extend deep into the soil, and simply scratching up the seed bed will not provide for infiltration of air and water to plant roots, and the soils may require deeper conditioning prior to seeding using equipment that is able to plow to the necessary depth. Here you can see a little section showing stair stepping detail. And also you can see the tracking on the slope. Blending soils to create a soil medium with a greater absorption capacity may be part of the plan of revegetation, and combining soils of different particle size increase the permeability of or moisture retaining capabilities of a soil. So seeding should be performed as quickly as possible after final grading. Hydroseeding, applying seed, fertilizer, mulch, and lime in a single operation, is the most efficient seeding method for large areas. Also, mulch is generally recommended for all revegetation projects, and mulch comes in a wide variety of materials with various characteristics. So, when we select plant materials, native species are a good choice. We already spoke about that because they have growth habits in the general soils of the area and in the climatic conditions. Plant selection must consider the growth, um, rooting depth, and the rate of establishment of specific plants. The time of year for seeding is also an important consideration. The rate of maturation from germination and the expected temperature and precipitation must be appropriate. So here there's another chart in the textbook. You can see the criteria for selecting plants for restoration projects. Using sod. Although sod materials can be expensive and require additional installation efforts, sod is appropriate for certain locations and applications. When using sod, it is important to confirm that the material conforms to the requirements set forth by the government certification agency, usually the State Department of Agriculture. When using sod in swales or on slopes, some extra precautions are necessary. The pieces should be installed from the bottom up toward the top in horizontal strips with the long edges of the sod running parallel to the contours. When we enhance slope stabilization with trees, the deeper root penetration serves to bind the slope together and to provide additional cover and slope protection from precipitation. Although the tree has very little value in protecting the slope from erosion initially, it does not, it does, excuse me, it does have a role to play over time. The canopy provides protection from um, the sun and rain and shade to the understory. The expense of tree planting on very large sites can be offset by planting seedlings. Individual seedlings and installation costs are relatively low when compared to larger trees, but some investigation into mortality rates, species, and long-term costs is justified. The plan will reflect budget considerations, site characteristics, and available plant species. So in a few more images showing the tree planting on a slope detail. And also you can see the nitrogen fixing trees and shrubs. So the competition between plants and trees or shrubs may be a matter of concern. Um, the herbaceous strip would be fertilized. The alternating strip containing shrubs or trees would be fertilized for the woody plants and planted with an unfertilized herbaceous layer. And here there is another chart in the textbook, and that shows the characteristics of selected trees and shrubs for use in restoration. And there are a few, it's a long table, so please refer to that if you're interested, because that takes into account a few different species and regions. And you can see that is for basically all the climate conditions. So contemporary recommendations for planting trees discourage the pot even in native soils. The new understanding of plant growth recommends the planting pit be 5 times the width of the root ball, but only deep enough to situate the root ball at the proper depth. Organic matter can be added to the soil, and the root should sit on undisturbed soil to reduce settling. Trees should be of a species that is adapted to growing on the slopes, and seedlings should have had 2 full growing seasons in nursery beds prior to planting. Let's talk about streams. So in most urban and suburban areas, stream buffers are routinely removed or severely minimized as part of the development process. The developed landscape quickly concentrates and quickly conveys runoff to streams. Most of the runoff that reaches stream buffers is in the form of concentrated flow rather than the sheet flow that might occur in an undeveloped drainage condition. Protecting existing stream buffers and banks is far preferable to having to work on restoration and try to mimic what nature has already established. Most communities with stream buffer standards require a minimum total width of at least 100 feet, or that the buffer meets the 100-year floodplain standards. Here you can see the image showing the tree watering. And the goal of the stream buffer is to recreate or maintain to the extent possible the pre-developed conditions of overland sheet flow, infiltration, and the process of filtration and deposition provided by vegetation. In general, native species of vegetation should be encouraged and invasive exotics removed. Another diagram showing the section of the stream buffer design considerations. And there is also a table showing benefits of urban stream buffers. Streams are formed by water and gravity and influenced by geology and climate. Less obvious are the biological elements of a stream, which contribute to its function. Climate dictates the amount of water through precipitation and evaporation and influences the vegetation and the richness and texture of the soil. In humid climates, the action of precipitation and running water coupled with the biologic activity weathers rock into soil quickly. The velocity of flowing water is a function of the slope of the channel, the resistance offered by the stream bed and banks, and its depth of flow. Gravity and friction play important roles as well. Friction is the resistance to flow or the presence of obstructions that tend to impede the downward flow of water. The shearing action of water running over a stream results from the interaction of gravity and friction and causes the erosion of bed and banks. Stream obstructions cause increased turbulence and direct flow toward the stream bottom or sides. A purely hydraulic system could operate without a gradient because accumulated surplus water can generate its own surface slope and is capable of flow on a horizontal surface. So um, to reach dynamic equilibrium, which means the amount of water and sediment that enter a stream are equal to the amount of water and sediment that leave it, the stream will adjust its channel to reflect changing conditions in the watershed. So a stream in a state of dynamic equilibrium is called a graded stream. So a couple images show a natural stream and a stream with falls and step pools. And we are continuing to the uh, sinuosity. So water does not flow in a straight line. The line connecting the deepest parts of a channel is known as the thalweg. Even in channels that appear to be straight, the thalweg will shift from side to side and ultimately create an alternating series of bars. Straight stretches from um, straight stretches often contain alternate bars, material deposited on the channel bed along the sides, alternating down the channel. And the distance along the center line of a channel or channel length divided by the distance between meanders is used as a measure of stream sinuosity. Sinuosity refers to the classification of streams into three types of patterns: sinuous, braided, and meandering. These are relative patterns, and there is no bright line distinction between them. The process of stream meandering is complex and difficult to accurately model. Stream behavior is a function of gradient, volume, quantity, and character of sediment, channel roughness, and composition. So let's talk about the stream assessment. The most commonly used method is the Rosgen method, and it is fairly sophisticated method that requires specific training. So it's performed on 4 prescribed levels, and although it's fairly comprehensive, it contains the necessary flexibility for the assessor to modify the method to the stream. So the first level is geomorphic characterization, which uses aerial photography and topographic mapping to identify the stream as one of the 11 valley types characterized by the gradient of the stream and the topography of the valley. The morphological description is the next level, and it involves a more detailed assessment using actual measurements of the stream. And there are 94 categories based on the degree of entrenchment, the ratio of width to depth, surface gradient, the stream bed materials, and sinuosity. The third level involves using the findings and experience of the first two. And from these first three levels of evaluation, preliminary conclusions can be drawn. This conclusion inform the fourth level of inquiry, which uses measurements of stream flow, stability, and sediment over time. So there is picture showing a stream restored using this method. And we are moving to the riparian zones. So healthy functioning streams are not strictly hydraulic or hydrologic systems. They're the result of a combination of the hydrologic and biologic landscape processes. Therefore, a key element of stream quality is the health of the contributing watershed. Vegetation and biotic elements of riparian systems contribute to stream quality in the following 5 ways. And the first one is roots of trees, sedges, and shrubs bind the soils of banks to increase the stability of stream banks and resist erosion. Two, overhanging vegetation shades streams, which keeps water along the edges cooler. Then the third one is biotic debris, decays and provides nutrients to water. And biota contribute to the health of riparian and upland soils to increase infiltration and decrease erosion and sedimentation of streams. And also animals build dams, wallows, and other features. So when we talk about the stream bank stabilization, it requires careful consideration. So for example, an under design stabilization may not be able to resist the velocities and energy of a flood and will be damaged or destroyed. Here there is an image showing a well-developed riparian zone and the stream section with dysfunctional riparian zone. So you can see how they are different. So many early stabilization projects consisted of merely armoring the stream with various materials specified to be heavy enough to resist flood conditions. But these methods have evolved from the experiences of community activists and sportsmen interested in stream quality. The watershed interest groups in most communities in the US take care of that, and they have acquired a great deal of expertise in watershed and stream corridor protection. The protection and cooling effects of overhanging vegetation and bank angle cannot be overlooked when assessing stream banks, and the angle of the bank also contributes to protection and cooling. Another image showing measuring stream overhang and measuring shade and the bank angle. So please take a look at how that is done. Um, so it's important to determine the stream width as opposed to the water width on the day of the assessment. A stream assessor usually measures the stream or channel width as the distance across the channel from the edge of terrestrial vegetation to the opposite edge. So here you can see a section in the textbook showing timber bank restoration detail and the fiber bank restoration detail. When we establish stream bank vegetation, that provides mechanical stabilization of the bank by its roots and acts to absorb some of the energy of flooding. If there is substantial traffic, pedestrian or agriculture, or a great deal of shade from overhanging trees, it's sometimes difficult to reestablish vegetation on eroded or damaged stream banks. Let's talk about live stakes, and they are living woody plant cuttings that will tolerate cutting and still be capable of quickly establishing a new root system. They are usually fairly sturdy and will withstand being lightly driven into the stream bank. The live stake is substantial enough to withstand light flooding and traffic and will develop into a fairly robust shrub or tree in shorter order. Live stakes of half-inch to 1.5 inch diameter and from 2 to 2.5 foot long are installed during the dormant season and at low water. Stakes are alive with bark intact and branches removed. The butt end is usually cleanly cut at a 45-degree angle, and the top end is cut flat to facilitate driving. All cuttings should be fresh and moist and not stored for more than a day prior to installation. It's preferable that live stakes be installed the day of cutting. And let's talk about branch packing. And it's often used to stabilize small washed out sections of a bank. Branch packing involves filling a washed out or excavated area with alternating layers of soil and live branches. So this method also has been used underwater. Branch packing is done during the dormant season and when water levels are low. A crib wall using logs is a more robust version of branch packing. This method is used in areas larger than those branch packing might address, or in places where strong currents reduce the effectiveness of other methods. As the structure rises, it is filled with the soil and gravel mixture, and then at the top of each log facing the stream, live cuttings can be installed. And the size of the crib wall structure may limit the opportunity to bring the live stake in touch with the original bank material. So you can see the branch packing detail here. There's a section and you can refer to that and see how that is done. And you can see the alternative detail as well. And you can see the crib wall detail. So when we talk about non-vegetative bank stabilization is not a practical option. Um, Such cases require stream hardening and the use of different strategies. But for the most part, this type of hardening does not refer to the capture and channelization of streams into concrete troughs. Let's talk about other two ways to accomplish this task, and those are gabions and deflectors. So gabions are rock-filled wire baskets that are wired together. Although gabions require heavier construction methods than do live stabilization methods, they can provide effective bank stabilization. The great weight of some stone structures create a gravity mass that is designed to resist expected flows. So gabion walls are keyed into the place below the stream bed and are installed during periods of low water. For installation using live cuttings, the gabion must be installed during the dormant season as well, if that is something that is planned. The installation of the gabion involves keying in the first layers of the structure. The bed is excavated and compacted to prevent settling and slumping. The gabion is set into place empty, then wired together and filled with stone. And if the filled basket requires an adjustment, it's usually winched into place. Deflectors. They are used to divert flow away from an eroding bank or to deepen a channel. They're fairly simple to construct, and many have been installed by local conservation groups to improve habitat and stabilize streams. So deflectors can have a negative impact on streams if not carefully designed and installed. Deflectors are ineffective or even harmful on narrow or very fast streams or for stabilizing banks at deep pools. Another image showing the stream flow deflector. So the objective of most deflectors is to direct the current away from the bank and into the center of the channel. The deflector must be substantial enough to resist the energy of the stream at various levels of flow. And the most common design involves constructing a triangle with a 30, 60, or 90-degree angles, with the short leg facing downstream and the long leg anchored to the bank. Deflectors can be built of logs or stone, and they're anchored in place and to each other using the steel rods or rebar driven at least 3 feet into the stream bed. Um, so let's talk about wetlands. That's the next subsection of our chapter 9. So wetlands are areas saturated by water often enough and long enough to support vegetation that is typically adapted for life in wet soil conditions. So the wetlands play an important role in the hydrologic cycle and are very productive environments. So the biodiversity is both for plants and animal life, and hydric soils are identified by color and include glade soils typical of wetlands, such as dark clays, as well as rich organic soils. Wetland hydrology is usually identified as areas ranging from saturated soils to soils submerged up to 2 feet. Wetlands can be tidal or non-tidal, forested, shrub, scrub, or emergent. In the US, there are approximately 100 million acres of wetlands that still remain. Coastal wetlands make up only about 5% of the US wetlands, and remaining 95 are inland wetlands. So, but also it's important to mention that some 22 states have lost at least 50% of their original wetlands. And from the mid 70s to the mid 80s, wetlands were lost at the rate of almost 300,000 acres per year. And that's the EPA study in 1991. Um, so, Section 404 of the Clean Water Act requires permits for the discharge or dredged or fill material into waters of the United States and wetlands. The 404 program is administered jointly by the Corps of Engineers, which issues permits, and the EPA, which retains oversight and veto power. The program allows for two types of permits, individual and general. Individual permits are provided for special circumstances not covered by the array of general permits and are subject to fairly intense review. General permits or nationwide permits, NWPs, are provided for many activities incidental to development that are perceived to represent relatively minor impacts. NWPs are available for maintenance, that's NWP3 utility crossings, NWP12 minor road crossings, NWP14 stream and wetland restoration activities, that's NWP27 reshaping existing drainage ditches, that's 41, recreation activities 42, and stormwater management facilities 43. Wetlands are mapped by the Department of Interior using high-level infrared photography. Soils maps can also be used to identify hydric soils, but wetlands are delineated in the field. Hydrologic conditions may vary from year to year, but soils and mature vegetation tend to be reliable indicators of wetland conditions. When we talk about constructed wetlands, we need to remember that key to the long-term success of creating a wetland is the design of the hydrologic element. And location is critical here. Finding a location that has the hydrology or can be adapted to have the hydrology necessary can be a challenge. Selected sites should not be subjected to significant grading due to the loss of soil structure associated with these activities, and supplementing the existing soil with hydric soils has been successful in keeping vegetation and microflora and fauna in the built wetland. The biological oxygen demand, or BOD, of untreated animal waste is about 100 times that of treated wastewater from a sewage treatment plant. And today, wetlands are being built especially to collect and treat wastewater and runoff. Um, since 1988, wetlands have been created in the US to collect and treat runoffs from feedlots and barnyards. So here you can see an image showing a wetland created in a highway clover leaf. So though the wetlands are characterized by vegetation, it's not the plants in most cases that clean the wastewater. Rather, the plants provide the oxygen and habitat for a variety of bacteria and microorganisms that break down the solids. The plants use the released nitrogen as a primary nutrient. Constructed wetlands have been notorious for having problems and for failure, and this should be kept in mind during the planning process. Restoration projects require careful planning, as we already know, and realistic performance goals should be established. The performance goals provide a clear measurement of project progress and success, and the professionals should clearly identify benchmarks of progress and success to demonstrate the value of the work to current and future clients. Restoration planning. So, most restoration designs understand and rely on the system's capacity to add complexity to itself as it matures. The supporting hydrology is critical to the wetland's success, and wetlands draw water from several sources, including groundwater, tidal water, runoff, and precipitation. Understanding the water budget of a restored wetland is a critical part of planning. A natural spring, a pond, or groundwater is usually considered to be the best source of supply for wetland restoration. Springs and seeps are often subject to disturbance during construction and should be protected if they are intended to be used to supply the wetland. Also, grasses play an important role in the most natural wetlands and vary usually in accordance with the depth and duration of flooding. Wetland protection. To reduce the impacts of development on downstream wetlands, stormwater should be managed to retain as much water on a site as possible by minimizing practices that result in runoff and using features to increase infiltration. So there is a chart showing the wetland plants according to preferred water depth. And when you plan that, please refer to the specific um, plan that is designed for your depth. And that is different depending on the region. And also there are a few comments as well as far as like what states it can be implemented in. in the depth of the flood. Erosion damage, that's the next subchapter here. So damage caused by erosion is often difficult to repair because the impacted area is usually subject to repeated episodes of erosive flows of water. So for areas with velocities that exceed the ability of the soil to resist shearing, it is necessary to provide at least temporary geotextile protection. Some sites may require permanent protection, and similar steps are required for eroded slopes. So let's talk a little bit about brownfield redevelopment, and that is our final sub-chapter here. So what is a brownfield? They are generally abandoned sites or properties significantly underused and undervalued because of environmental contamination of the general perception of or the general perception of contamination. And the risk associated with owning contaminated property was exacerbated by the Comprehensive Environmental Response Compensation and Liability Act, and that is often referred to as a Superfund. So that made landowners liable for contamination found on the property, whether the landowner had caused the contamination or not. So in 2002, President Bush signed the Small Business Liability Relief and Brownfield Revitalization Act, and this law modified the federal policy on brownfield and increased the resources available for brownfield assessment and remediation. A number of important changes in the law deal with funding, municipal waste, and support for state programs. So this law statute provided purchasers who could demonstrate they acquired the property without any knowledge of the presence of contamination with the innocent landowner defense. And also site development practices sometimes must address residual contamination as part of site development. On such sites, environmental issues must be accounted for in the construction phase as well as on the build site. Most states have voluntary cleanup programs or VCPs or brownfield programs of one sort or another. The interest from the private development community is based on whether there is a good real estate deal on the table. When we talk about liability protection, so state programs may provide buyers with protection from the liability of the state superfund programs. Since state laws do not offer protection from federal liability, many states have entered into Memorandum of Understanding or MOUs with the federal agencies. So liability protection from the state program is managed in a few different ways. Like some states provide a document that acknowledges the state's agreement not to pursue any further action on the site. And under some other programs, the state agrees to assume liability for contamination, in essence, standing between the property owner and the risk of undiscovered acts of the past. So when you plan the redevelopment of a brownfield site or brownfield remediation, the presence or concern for the presence of hazards on a site may complicate even routine planning decisions involving the use of the soil on the site, grading, stormwater management, and construction methods. For example, whereas stormwater infiltration strategies might be encouraged on a green site, they may be discouraged or even prohibited on a brownfield site to prevent leaching of contaminants. There are cleanup standards, and it's difficult to determine a comprehensive standard for site cleanup that is not so conservative as to be impractical in most cases. A range of choices allows the developer to prepare a strategy that balances the site issues and resources, and the more stringent standards are costlier but result in greater risk reduction. So, in general, um, removing contaminant soil from a site and properly disposing of it off-site offers a relatively quick and final solution of the contamination problem, but it can be very expensive and the owner retains some future risk. Capping a site is a frequently used strategy. It can be cost-effective and implemented fairly quickly, but all the contamination remains in place. Bioremediation or phytoremediation may be very effective and have much lower costs, but these processes tend to be taking a long time, often requiring extended and difficult to predict time frames. So when we talk about risk management, there is always a degree of uncertainty in risk assessment because the efforts are limited by how much we know or the accuracy of what we know. The risk assessment process for environmental contaminants is fairly straightforward, and there are a few steps beginning with a clear definition of a problem. So the next step is to determine the amount of exposure a person would have to a substance, and also studies of animals are not same as studies of humans, and for environmental risk assessment purposes, extrapolation of such studies is not an acceptable practice. So information should serve to help people understand and evaluate risk. And there's a tendency to communicate risk in familiar terms to help people understand, but caution should be used when using comparisons. Lifestyle risks such as smoking or drinking are voluntary, are not valid comparisons with risks that have been imposed on someone. So you can see there is a table showing the concentration analogies, and they can help people understand quantitative measures such part per million or parts per billion. General strategies for brownfield projects um, actually are limited to doing nothing, using administrative or institutional controls, using engineering controls, on-site remediation action, or off-site disposal or treatment. Owners might have to carry specific insurance or provide some kind of performance bond when dealing with the brownfields. So a broad range of technologies and strategies are available for an on-site treatment. And you can see there is a table showing types of remedial technologies. So those are solidification, then soil vapor extraction, incineration, bioremediation, soil washing, solvent extraction, dechlorination, phytoremediation, air sparging, passive treatment, wells. So there are a few technologies available. So as far as the design concerns go, brownfield redevelopment employs all of the techniques and materials that are usually used in the site design. Uh, just there are some extraordinary steps for the brownfield remediation. When you develop on a capped site, constructing a cap on the site isolates and contains contaminated material from receptors and from natural transport mechanisms. And most development involves the installation of underground utilities and infrastructure that, by definition, penetrate the zone of contamination. So plans requiring the installation of utilities and contaminated materials should be re-evaluated. So also the best practice is to isolate the utility trench or foundation excavation from the contaminated material by lining the trench with a cap material or another alternative. And here you can see a section showing lined utility trench detail. And also you can see the picture of a fully revitalized brownfield site. And that can be both a source of tax revenue and an economic engine in the neighborhood that would otherwise be abandoned. And that was it for our chapter 9. Thank you so much for watching. I will see you in chapter 10.